Hello, welcome to another Sunday. Happy Sunday. If this is your first time here, say hi. And while we're waiting, I'm going to remind people that we're live. And then we'll get going. If you've got any questions, throw it in the chat at any time. I'm happy to pause what we're doing today and answer. And I think today is going to be interesting. We're going to talk about. Sorry, fighting with my social media. We're going to talk about the macros that are inside Tesla, which I think are pretty interesting, the way they're designed. And it's also reminding me of some stuff that I had done when I originally built this library. Now we're rebuilding it from scratch. And I think it's going to be a lesson in how to design a nice macro, utility macro for a library that you publish. So pretty interesting stuff. And I had forgotten about it last time we did a coding session. So we'll get started in just a few moments here. Okay. And I have been posting this across all of my social media, try to get people to join. And I don't know that it helps. We'll see. I would love to know from all of you who are coming where you found out about it, because I've been posting on Twitter, on Mastodon, on Blue Sky, on LinkedIn, and today is my first post on Reddit. I'm also on Spoutable, but I don't. It's so small right now. I don't think that most of my tech community is on there. So we'll see. Maybe I'll start a poll in the chat or something, and we can. Oh, great to come from Reddit. Thank you. I was a little bit concerned about the Elixir community thing on Reddit being like, hey, no showing this self promotion, and so I tried to keep it as as non-promotey as possible and informative. All right, so welcome, J.R. Bart and Najabosi. I'm sorry not pronouncing that correctly. And let's get going. All right, so for those of you who are new, we're building an HTTP client. It's a high-level HTTP client. And what I mean by that is we're not concerned with the mechanics of managing TCP sockets and framing of HTTP messages on that socket. We are only concerned with how do we make something between that low-level interface and what you would want to use as an application developer in a production service. And so this is about building on top of that low-level HTTP client the tools and techniques you'll want to integrate as you make your HTTP calls observable and reliable and basically just like everything that you would want before you ship your app and are confident in it. So I'm going to switch over to my other view and we'll look at the agenda. So previously we have, just to refresh your mind, this is our repository, seancribb/hardhat on GitHub. So our client has connection pooling. So you must create a connection pool. That is one of the principles that we're putting in here. And the first session we did, unfortunately, the recording got lost on Twitch. I didn't record it separately to upload to YouTube. But every subsequent one has been posted to YouTube as well. So you can get those. But the idea behind the connection pool is every destination service that you're calling should have its own connection pool so that you don't interfere with each other. In a previous job where we ended up billing this, I saw cases where we had one connection pool for all outgoing client connections, and if one particular service was being hammered, it would consume all of the connections, and then other things would be starved. So having a connection pool per destination service is really important. We made that configurable. Last time, was it last time? Okay, so we did, I don't recall, yeah. Our second session, we added telemetry, so the Erlang telemetry library that everything integrates with. And we added open telemetry for distributed tracing, which is really important. And then last time we added circuit breaking with the Fuse library by Jesper Lewis Anderson, and that's for bailing out early if something is repeatedly going wrong. And today we're gonna do a few administravia things. So I'm gonna set up Dependabot first. It should be pretty quick, just a few minutes. We're gonna talk about because our client is built on top of Tesla, which is a great library, and I want to look at, because last time we did something that I felt like, gosh, this is so cumbersome. We're forcing people to use module attributes to configure the Fuse middleware, and that's not great. So I alluded to it a few minutes ago, but we'll look at how we can make use of the way that the Tesla plug macro works, to make that so that it's more dynamic and less compile time. And then we'll talk about timeouts and deadlines. So I'm planning to go for about 2 hours. We'll probably just go until we've gotten through all the topics that I've outlined here in my little checklist, and then we'll wrap up. If you just got here, this is your first time here, thank you for coming. And please do drop questions or comments in the chat. I've been doing Erlang and Elixir for a long time, but it's not my day job right now. So if you see me do something that's really silly and I can't figure out what it is, please, I don't mind being corrected. We can call this mob programming if you like. Okay, so let's get set up with Dependabot. And I did a little Googling earlier, and because I found this, I was looking at the Insights panel, and it recommended that we set up Dependabot, and I figured, if I'm going to keep this going, we might as well make sure that we're on the latest versions of everything whenever possible. And then I Googled a little bit about how to set this up, so honestly, we're just going to get started with that. All right. So you may notice I'm using two different editors. Emacs is my old love, but we've kind of had a falling out lately with respect to language server things, and I wasn't willing to give up on the Spacemacs distribution. So anyway, we've got our checklist in Emacs, and then we've got our normal coding over here in Zed. So I'm going to copy, and we're gonna tweak this because I don't think that daily is absolutely necessary, but we need to add a GitHub dependabot.yaml. So yeah, YML is fine. Okay, so, and it looks like we've got some syntax problems. Yep. what's going on here. Implicit keys need to be on a single line. Okay, actually that was the thing that was wrong. Right, this needs to be on its own line. And we may have to fix that. Okay, so reviewers, we're just going to put my name in there right now. Yes. White space languages are the bane of my existence. Okay, I think it's like that. Okay, so hopefully interval, I'm not going to do daily. Let's do weekly because I don't think that we need more often than that. I'm really only coding on Sundays, so if it makes a new PR every week, that's probably fine. And just to be sure, I'm going to go over here. We're going to close that. I believe it was in here. Community standards. Actually, it was in here. Dependabot. So yeah, YAML, it's evil. I like it. I prefer it like this. But let's see what. Okay, so schedule needs to be part of that. So why don't I? Well, let's start over because this will be really easy now. Okay, so mix and weekly. Okay. Location, the package manifest. Yeah, read the repository. Okay, cool. So thank you, GitHub. And now it's not complaining about the formatting. That's what I get for trusting a blog post, right? Okay, so let's commit that real quick. Add Dependabot configuration. Okay, and let's push. And I was previously over here. And yeah, so it's got that. It's checking for version and security updates, and we can check that off our list and move on. Okay. Yeah, YAML's technically JSON compatible. Can't we just agree on writing JSON instead? Yeah, well, JSON isn't very user-friendly either. Okay, so we added Dependabot. It's funny, back, gosh, like maybe exactly 10 years ago or so, we were fighting with communicating to our customers how to configure our product. And at the time, you may remember, if you've been around as long as I have, or maybe not even that, people weren't, like, Kubernetes wasn't a thing yet. People were either like deploying to Roku or running their own stuff on cloud or on-prem. And we had, Terraform didn't exist yet, or maybe it was really, really new. And so people configured things with tools like Chef and Puppet and CF Engine and stuff like that. And they made it really hard to build structured configuration like YAML. Those, like, YAML has indents and whatnot. And so we said, well, if it's going to be easiest to do flat, why don't we make the format flat? And then the structure can be and it could just be like key equals value, and the structure can be in the key. And then so, like, it's easier to read as a human. But if you're automating your deploys of this app, you can you can just go key equals value. So so we made that, shipped it in our product, and I think it was generally good. Building, like designing the config itself was kind of interesting, because you had to basically make a flat file, but like have structure and like create structure for the configure, because this was an Erlang app. Create structure for the configuration of the Erlang app, and out of that flat format. So it was kind of complicated, and I'm getting off track here. But if you want to look up basho/cuttlefish, and you'll know what we did 10 years ago. Okay, so I mentioned this before. The plug, excuse me, I'm gonna toss my gum. The plug middleware. Um, we added the fuse middleware. Let's look at our builder real quick. And I might, I might switch this down a notch. That's still readable and a little bit less in my face. Okay, so last time we added the fuse middleware and we had these thresholds, and okay, they're a module attribute. And this is injected into the client that you create, right? So I don't really care for that. And we did this thing down here, right? So we used that module attribute that was injected in there before compile. So again, like I said, I was really unhappy with this. So what I'd like to do is to make it so it's easier to override this. And especially if you want to change a configuration at runtime. So like at startup time, you put something in the application config. And then, that way you don't have to redeploy necessarily to tweak your fuse settings. Like if it's triggering too quickly or not quickly enough, you might want to run a command that happens across all of your instances of your app, that sets those fuse thresholds, and meanwhile set it in your config that you deploy with, so that next time you run a deploy, it sticks around. Okay, so what we're going to do is we're going to figure out how we can get this out of here and make it more runtime friendly. I went digging in the Tesla source, and this is the plug macro. So this gets put in scope when you do use Tesla.builder, which we do up here, right? And Tesla registers this middleware attribute. So in the module that is being emitted, in the context of this use macro, it creates a module attribute which is dunder middleware. Okay, and it says accumulate true. This means that every time you say, set this middleware module attribute, it's going to add a new one rather than overriding the one that was there before. Okay. Okay, so that's a lovely story, by the way, about deploy tools for automotive. Okay, so the plug macro, as you can see, we did down here. This is how we add a middleware to our stack on our client. So what does it do? So it has two arities. One, it has the 2 arity and the 0 arity, or the 1 arity rather. So when you do that, it's going to add, because we registered this as accumulating, this attribute, it's going to add another one. And here's where it gets really interesting. So whatever you passed here to this, it's going to escape it and then unquote it. Okay. And then it's also going to take the options that you passed and escape that and unquote it. And then this little bit here is not used. It's really just tracking information about where this was called. So what I want to do is I would like to. We're gonna put in a little thing here. We're going to put in, because our, actually let's do inspect. Our before compile will run before Tesla does its before compile. That's how we're able to inject these middleware before it creates the function that contains the list of middleware that was set at compile time. So what I would like to do, thank you, Mitch, debug. Yeah. Is it IO debug or is it just debug? Hi, Mitch. Debug is the new hotness. Well, I'm old school. Let's just do IO inspect. And then what I want to do is mix compile, because and okay, so there's nothing in it. That's fun. But if we do, you can see it's a list. So let's do it at the end here, after we've injected all our middleware. Kernel debug. Thank you, Mitch. We'll try that later. Okay. So this is fun. There's a lot here. Let's go up. Okay, so the Elixir compiler is adding aliases here so that so this is saying this has escaped this module name, right? And it's got the metadata about that particular AST node. And this is the module sequence, the sequence of module names. And so aliases, and note that we have turn off slow mode so I can spam the chat. No thanks, Mitch. Okay, and then this is sort of the information about where the call happened, and the context of that. So, and there's a lot of goop there in that middleware piece. Now, interestingly, as you would expect with Erlang or Elixir, you always put things on the front of a list. So when you accumulate that module attribute, it's putting the last thing first. Okay, always consing onto the head. Okay, so it added our path params, and I want to get down to some of the things that are a little bit more interesting. Okay, and then there's open telemetry. Okay. And we didn't pass any options to that, so it's not. So we're getting here this one, right? It's only unquoting the name of the middleware and then that extra stuff. Okay, let's keep going. Okay, and then telemetry, which we didn't modify either. It has no arguments, no options. Okay, so now we're down to fuse. Okay. So, yeah. Thank you, J.R. Bart. So we've got here we've got it slightly different. So we've got the module name, Tesla middleware fuse, and then it's got ops. Notice this is not like, this is not a symbol. This is not an atom with fuse thresholds, right? It's actually, so this is right. So ops is the key that is required when configuring the fuse middleware, and so that gives us it's referring to this module attribute, right? And then we have keep original error true and should melt. So you can see here that it's actually escaping this. It's not taking the actual value at compile time. So in this case, see we have a capture, a function capture, and then we have, this is a module function delimiter here, or rather function arity, and we're doing dot. So this is all AST, right? Except for where they're bare terms. This is one of the weird things about the Elixir AST is that, like, when you have a term that is immediate, like an atom or an integer, for instance, you don't have to have like, oh, this is an integer tuple with here's the value and here's all the metadata. It just puts it right in there. So the moral of this story is, and I'm getting to it, I promise. The moral of this story is we can take this stuff and rather than putting it directly here, we can use a function call, right? So here's what we're going to do. Let's make, we have this defaults module which has all of our things that can be overridden. Okay, so let's make a new one, and this we'll use this pattern in the future when we need to. Okay, so default implementation of the options to the Tesla middleware fuse. I think that's what we did for, okay. That is in, is included in the default middleware stack. Okay, so we'll do def fuse options. Let's do that. And oops, let's go back over here, and I'm gonna cut these out, and we will and now this part is probably going to be what we're going to do is we're going to pass mod here, and that way it'll always refer to the module rather than this module, the defaults module. It'll always refer to the module that is implementing the client, that the macro has included our code in. And so and then let's remove this this module attribute and just put the defaults in there, and then we will document the defaults. Okay. Right. Okay. So what we're going to do, this is a little bit tricky. But what we will do here, instead of doing a def delegate, we will do def fuse ops with the 0 arity, and then we're going to call hardhat.defaults.fuse ops module, right? That way we get these defaults. Yep. And I think what we'll do is we'll say, is it C? How do we document that? We'll just do doc C hardhat dot defaults dot fuse ops 1 for okay. If there's a better way to do that, please drop it in the chat. Like in Erlang docs, there's this @c thing. I don't recall what it is for Elixir. Okay, so so let's document this, and then we can commit this and move on, and we can remove here. So we did. Let's do fuse ops. Right. Okay. Okay, so these defaults include. No, why are you trying to suggest alarm handler? Okay, so the fuse will blow after 50 errors within 1 second and reset after, let's use numbers, 1 second and reset after 2 seconds. The original error will be returned when a fuse first blows. Okay. The default should melt function is used. See, well, that'll link to it, right, in the docs. The fuse uses async dirty mode to check the number of failures or the failure rate, which may result in some delay in triggering the fuse under high concurrency. Okay. But this is important to say, I think. But it will not serialize checks to the fuse state. Through a single process. Okay. And I think it's worth putting the keys in here, what these are. And maybe we can say okay. Okay, and see tesla.middleware.fuse for more information on how to configure this. Okay. Um, so let's go back over in our builder, and I'm going to leave this for one time, and then we'll clear it out before we make the commit. So, yep. So let's compile again. And we should see our last one was fuse. And this may not be correct. It does look like a function call, but just for safety, yeah, let's just for safety say module. And then what we can do is we can run our tests and see if they still work, because we really just move things around. We haven't changed the behavior of the fuse middleware or anything like that. So let's compile again and see. Right, okay, so now it's going, you know, there's a dot, right? So that's the application operator, module, fuse ops, right? Okay, so this is what we want. And let's actually just say doc false on this, and fuse ops 0 can be overridden. Okay. So I'm trying to. Sorry if this is not necessarily clear. What I'm trying to do is walk a line here between choosing good defaults, but also giving just enough customizability that whoever uses this can tweak it to their particular needs within their infrastructure. Okay. So let's remove this IO inspect middleware, and then real quick let's make sure that the tests still pass. Yeah, and they don't. Okay. So let's see what has happened. Okay, so we may have a race condition here. Before we do that, let's do mix decompile again. Make sure I don't have it. Okay. To expanded Hardhat, because remember last time we generated a default client, and then okay, so this is what, after all the macros are expanded, what our module looks like, and this will make sure that those changes that we did to the macro. Yes, Evans, we'll let the user change the configuration at runtime. So we should probably make an example for that. But let's scroll down until we get the last things that are generated by the Tesla builder. Okay, so you'll note here that what happened was in our builder, we said plug Tesla middleware fuse, and then we say current module dot fuse ops, right? And now in our stack, we have this, and you can see that when Tesla figures out what the middleware is for the current request, it's going to call our fuse ops functions. So we should have a fuse ops in here that was generated. And here's what it generated. Okay, so it's going to call that function, passing our module name. Okay, cool. So just to be a little bit paranoid, let's do describe fuse options in our test. Um, and this and this is why it didn't work. Right? Because we changed the way, this is why our test failed, because we changed the way that this is set. Okay. Um, so it's no longer going to be set with a module attribute. It's going to be set by overriding the function. Okay, and we set this so that we could trigger those failures more quickly. All right, so we're going to leave that there, and we're going to say desfuse ops. And we're going to say ops, and then we'll just use this because we have it here, and then I don't have to. You know, we're going to go one step further. We're going to say hardhat.defaults.fuseOps module. And then we're going to do, we'll pipe that to keyword put ops fuse thresholds. Okay, so now we've overridden that. And then, like, if we were going to make an example of what you might do instead, is you might do something like application get env. And then this is like, you know, whatever the name of your application is, and then you might say module, and then give some defaults instead, or you might say so like that's the sort of thing that you might do when you're trying to make this configurable at runtime. And you know, I think there were some arguments when we first did this at the job where I built this the first time about, oh well, is that like bad to do that on every request? The answer is no. The application environment is an ETS table. ETS tables are super stinking fast, and the OTP team has put a lot of effort into making ETS tables fast and keeping them fast. So if your bottleneck is an ETS table, I don't think that your problems are related to doing HTTP requests, because they're like on a different scale in terms of the amount of wall clock time or CPU time it takes. And I'm going to do a little stylistic thing here, even though it's bugging me. We'll do that. Pipes. What are you gonna do? Okay, so now our test should actually pass, and then I think what we should do is we should check the output of our middleware, right? So let's say get injected into the middleware stack for Tesla.middleware.fuse. Okay. So let's call test client.middleware undocumented. I'm pretty sure it's public. It has to be. Okay, so and then what we want to do is find. I closed that Hardhat thing. So what we're looking for is let's use a list.keyfind probably. Let's say fuse middleware. And if there's a better way to do this, and let's say key is going to be Tesla.middleware.fuse in position 0. And if there's a better way to do this, please let me know. Okay. And then we can say something like assert like we can match on this, right? So we're going to get, why don't we pattern match this, right? Let's do an assert here too. And this is going to be call, and this is going to be ops. Okay. That line's getting long. Okay. So let's assert that keyword fetch ops, and I'm sorry that that's okay. So yeah, so this is checking that we are getting this as our value for the options. Let's run the test real quick. Okay, so now they passed. We added a test. And we could do more things here. I don't think that it's strictly necessary to test all those other things. It's really that what we're testing is that this gets called when it sets up a new request. So I think we're good there, and it's probably time for a commit. So you know what? I'm gonna edit the git ignore, because I think I'm gonna say mix decompile output. We want elixir dot star dot ex or url or s. I don't know that we'll ever use s, but and then let's look. Yeah, that's not working. All right. Let's try that. Yeah, now it's ignored. Okay. Let's make a little commit, which is just ignore mix decompile output, because we don't ever want to commit that. Okay, and let's look at our diff here real quick. Okay, so we added, we removed the module attribute. We added the default fuse options. We made it overridable. Okay, and then we changed our middleware in our before compile to call fuse options as the contents of that. Right. Okay, and then we added documentation for the defaults, and then they're there. And I might want to document this argument before we commit there. Okay, and then we updated our test and we added the middleware configuration test. Okay, so yeah, let's update the documentation here. The should melt function defined in the client module is used. Takes the client module name as an argument. Okay, and then it's a bit more clear about what this mod thing is, and so and why we need it, and maybe by default, and let's add some more detail here. Is the is hardhat.defaults.shouldMelt. Okay. Oops. Let's get parens in the right places. Okay. Right. Time for that commit. Let's look at our status and our diff again. That'll be pretty good. Okay. Let's commit that. And as I'm writing this commit, this should be a good time for questions. So drop them in the chat if you have any. Refactor fuse options. Okay, I don't think that we really need to say anything more in that commit message. Okay, and let's go ahead and push. And real quick, I'll check that our wonderful actions that were provided by Mitch are, yeah, I know it's not protected. We'll do that eventually. So our actions are running. And cool. Test pass, stylizer, we're not going to wait on. Okay. Okay, so we talked about that. We'll get to that in a minute. All right. Let's look at our checklist. So we updated this. We're not using module attributes anymore. We're using runtime option injection. And, you know, quite frankly, we might at some point do that for other middleware. There's not really any options on these that are relevant. Maybe OpenTelemetry has some, but I don't recall. We might look at that in a future stream, see if there's anything more that we can. Hey, let's view that on HexDocs. Ah, page not found. Cool. Okay. And, you know, we did our own middleware for path params. Okay. All right, let's look at the next thing. So we've completed those two. Let's talk about timeouts and deadlines. And this, I'm going to give a little lecture. Bear with me. Hopefully it won't make it too long. What are timeouts and deadlines, and why do we care? So all of the things that we're doing here in this client, aside from thank you, Evans, you're here for the lectures. Aside from instrumentation, which is essential if you're trying to debug a running system, all the other things we're putting in here are about liveness. And I feel like it feels like every year whenever I'm doing something like this, We're giving a meetup talk. I ended up talking about either Little's Law, which we might get to in this stream at some point, or safety and liveness. I'm not going to explain safety and liveness and the difference between them, other than to use their colloquial versions. So safety is about nothing bad happens, and liveness is about something good eventually happens. Now, to put more context on that, that is to say, liveness is about, is your system up and running and still doing things? So the way you violate liveness, these are two like theoretical properties about distributed systems or about systems in general. But liveness is about, can you continue to do work? So what are the ways that you can violate liveness? You can stop doing work. So there are conditions like deadlock that you may have heard about with respect to threads, or interacting processes where they're both waiting on each other. Or, for example, if you're not in Erlang Elixir, you might have like a mutex, and if you don't use that mutual exclusion lock correctly, you could have if the order of acquiring locks is incorrect, you could have two processes or two threads that are waiting on each other's lock and they can't continue. That's called deadlock. Other types of liveness violations is starvation. So one of your processes, one of your threads never gets to do work because all the things it's waiting on are always occupied. And then the other thing is that some forms of distributed algorithms like consensus might not be live. So they might have situations where the parties involved cannot come to an agreement on what order of operations should happen or what the value of a particular register might be. And so what we want to do is make sure that you can always make progress, even if that progress means you stop waiting on something, right? So timeouts and deadlines are two flavors of the same thing, but they basically say, I want to wait a maximum amount of time for some operation to continue, for some operation to complete, rather. Timeouts are local. So they're only within your current context. So your current process, your current application, the current operation that you're doing. Deadlines, we will hopefully get to. I'm not sure exactly how we're going to do it, but we'll figure it out. Deadlines are about having a global timeout across your entire infrastructure. So why is that useful? Let's say that you have a very high traffic website. You might, for instance, want to make sure that new people coming to your website requesting things will have the opportunity to do so. And also, maybe you have some things that they're time sensitive. If you give a late reply on something, it's not useful. The other thing is that, I mentioned fuse in our previous stream being about controlling back pressure. Bailing when something isn't going to work and that you shouldn't try it. And that's a liveness technique. If that thing is never going to work, there's no sense in trying to perform that operation. And now it's fuzzy with respect to fuse, to circuit breakers, right? In that you sometimes need to say, okay, maybe I should try again. Maybe it's working now, which is also a liveness thing. So with timeouts and deadlines, maybe if you've got to make a call on behalf of the user to 5 different services, and you do it in sequence, and the second one, like service B, is going slow, then you might not get to fulfilling all of the other requests, right? And so within the time bound. And this is very, like, I think, specific to particular infrastructures, how you configure deadlines. But you're basically saying, okay, I want this total sequence of requests for whatever operation to last no more than a second. That's actually a pretty big deadline, pretty wide one on high traffic apps. But let's say you set it at a second, and if one thing takes up half of that time, the others have less time to complete within. And then these can be cascading. So for instance, let's say that a particular code path doesn't include a global deadline, but you might want to make sure that you don't, that you say, well, my SLA or whatever is still 300 milliseconds for this call, and I want to make sure that whatever things that other service I'm calling is doing don't take longer than 300 milliseconds total. So just like with distributed tracing, if you propagate this information across your infrastructure, then you can make these global timeouts, happen across tons of different calls. And then, similar to circuit breaking, if you can't meet that deadline, you bail early. You don't even try things that are not going to complete. And that's like a huge load. If you can think of, if you think of the operations you're doing as a queue, and you've got things that are in progress and things that are waiting, if your capacity, so the number of things that you can do in a particular time frame, is full, in order to stay up, you need to decide, do I drop new things or do I drop old things? And timeouts and deadlines are strictly on the drop old things, right? You want to accept new requests. You want to accept new work. Things that aren't going to complete in time, you should throw them away. And that keeps your capacity within a bounds that is manageable. Okay, so timeouts and deadlines are all about liveness. Timeouts are local to an operation, or to an HTTP call in our case. And deadlines are global across an infrastructure. So let's look at Tesla middleware timeout. Now that I've given my lecture, thank you for bearing with me. And thank you for showing your appreciation for the lectures. Okay, so let's look at Tesla middleware timeout. So this is the one that comes with Tesla. We might just use it. I'm not sure yet. So this is timeout the HTTP request after X milliseconds. Okay, that's pretty straightforward. Clearly, this is something that we're probably going to want users to put. It was questionable about whether Fuse should have some defaults for timeouts, but everything in everything should be configurable for the user, the creator, the client, right? So I don't think it makes sense to automatically put a timeout in our stack. But what we can do is make our own timeout middleware potentially and wrap this one, or even do something else, where when they say, plug hardhat.timeout, like we did with, we made our own path params. I think it was in middleware module, but then they can supply some options that we care about. Okay. One of the interesting things about this timeout middleware that has changed since when I used it and we built for the first time is that you can supply a module that provides the same interface as the Elixir task module, which is how it does timeouts. And yeah, and so that way, the big thing here is trace propagation. Now, if we add deadline support, we're going to want deadline propagation as well. So maybe what we'll do is let's make a mini middleware for deadline propagation. And maybe we'll get to that last. Yeah, so let's see if we can wrap this timeout middleware in our own middleware and supply this task module. Now I pulled this up. This is important to look at. Basically, if we don't use this library, what we would have to do is something like the following. Now, we may not start a span because that's not really, for the case of handling a timeout, we don't really need to create a span. But the other thing we might want to do is potentially add some add a trace event if our timeout fires. So if our task doesn't complete in the time, we might want to add an event to the current span that says timeout exceeded or deadline exceeded. So there might be still some motivation for us to write our own timeout middleware. And then we should have some very strongly worded documentation about please don't use the Tesla middleware timeout. It's going to break your app. Or rather, you're not going to get OpenTelemetry propagated, and you're not going to get deadlines propagated, and you're not going to get span events. So, right. So this is just talking about, how you might do this, and this is assuming you have a span going, and you run task async, and you could say fetch parent, which we might do that, and then you attach the parent's context, and this stuff is like what happens down in our OpenTelemetry middleware, so we don't need to do any of that. We don't need to create a span here, but as an example, that's how we might be able to do that. So if and the big thing here is this is a stand-in for the task module. So what we were seeing in Tesla middleware timeout is that you can say task module and give it something that basically looks like task, has the same functions. Okay, so let's look at what it does. This is highly factored code. Okay, so here it's saying safe async, and inside that it's going to run. So basically the job of this is to spawn a task, and then inside that task call Tesla run with the current request and the rest of the middleware. Okay, and we saw this in our other middleware modules. Is basically at some point your middleware decides what to run next. Okay, and it calls Tesla run. So down here in safe async, which is a private function, so it's calling the task module, which was configured and defaults to task. Calling async, and then it is calling the past function in a try rescue. Okay, so I think the idea here is that if you get an exception, you want to pass that up to the parent process. Right, and then it'll re-raise the exception if this gets passed through. So we might like copy pasta a lot of this. I think that's probably okay. And the other thing here is that we have to make sure that if this timeout from calling await, if the timeout happens, you call shutdown on that task so that it shuts down cleanly, and then you return error timeout. And this is the branch where we would probably do something like add a span event that says timeout or deadline exceeded. Now, yeah. Okay, so let's start with this. And instead of having this be configurable, let's do our own propagation. And yeah, default. Let's not do a default timeout. We'll do like you have to supply a timeout or a deadline. Yeah. Okay. And then we can copy pasta a lot of this. So just re-raising the exceptions, throwing exiting. There's one problem here, and that's if this returns error. And so like if there's a socket error, this will have a bad match, if I'm reading this correctly. So piping to repass error here, they're not. Oh, well, it's saying try okay, do okay func. Okay, so they're unwrapping this. I get it. Okay, so I was wrong. There's no, but you might have okay. um, where result could be is a Tesla ENV result, right? Okay, so let's. I gotta split. Thanks, Jr. Bart. Come back again next week. Hopefully, be running this again next week. And thank you for coming. Okay, so we had our own path params middleware. Let's just go ahead and make our own timeout middleware. There's a question in my mind about whether we do deadlines. Maybe what I mean by that is the naming of the module. Do we say it's timeouts or do we say it's deadlines? I think people understand timeouts even if we're going to incorporate deadlines. So, yeah. We're going to need some module doc on this. So let's make sure it's there. To-do. Okay, so this is going to be behavior Tesla.middleware, right? Right. Okay. And then let's copy pasta all of this. And then we'll start modifying it. Okay. Yeah, there's no default timeout. So what did they say? That time's out? Okay. Timeout HTTP request after X milliseconds. Essentially, that's what we're going to do. Includes automatic propagation of open telemetry tracing context. And let's make this a bullet list. Why does it really loves to say alarm handler when I put a colon. I must think I'm writing Erlang or something. Addition of open telemetry span events on when the timeout is exceeded. And then we will add stuff about deadlines later. I'm not sure exactly how we'll configure that. But we're definitely going to do, we're going to use fetch bang here. They have to supply a timeout. I think that's reasonable. We're not going to use our task module. Okay, and then our task module, let's go ahead and get that dependency. So we were looking at OpenTelemetry process propagator, right? And let's just copy it out of the URL. That's probably the easiest. Cool. Okay. And oops. Yeah, that's fine. We're gonna have to go back to hex docs anyway. Or the hex, because I need to know what the version number is. 022. Okay. Okay. Cool. Yeah. I'll stop trying to make keyword fetch happen. Thanks, Justin. Okay, so our task module is going to be, we'll start here. This one. Okay, we'll start with that. And so that achieves our automatic propagation of telemetry tracing context. But I think that what we want to do as well. Okay, so if the timeout is exceeded, here we want to tracer.add event. And then let's look at the docs for this. Right, an event. It's an event name. Okay. Okay, so it's just like a string, or we'll probably use. Okay, and then you can pass arbitrary attributes, right? Okay, we'll probably use an atom there rather than a string, because I think, yeah, okay. You're gonna make me look at the code, aren't you? You make me look at the code. And GitHub, open telemetry Erlang. Okay, we can find it in here. There's the OpenTelemetry module. Type event name is a Unicode binary or an atom, as I suspected. Okay, so what we're going to do is we're going to say timeout exceeded. And then we're going to do stuff like module, and that's the env. I gotta help out the language server here. Let's see if it'll give me a field name now. No, it won't. Okay, so let's jump to the definition of that. Okay, so it's this, right? Okay. module, and we'll say timeout, and anything else we need to put in there. I think for okay. That seems pretty good, I think. So we're adding an event that a timeout exceeded. We might there's a debate in my mind about whether we set the span status to error. I don't know how I feel about that, because clearly this is, an exceptional condition. We didn't expect this to take longer than the timeout. Let's look at that again real quick. Tracer set status. Status code, yeah, and it's going to do that to me again. Creates and sets the status of the currently active span. Yeah, I don't know that that's. Let's for now let's not set the span status, because we don't know in this context whether a timeout to a particular call represents an overall erroneous span, right? It's possible that someone could say, like, attempted to call this one within a timeout, and if it doesn't work, like, if we get this error timeout returned, then we might try this like fallback. So it's probably not reasonable to add an error to the span. But yeah. There's also a question in my mind about whether we should, at the top of our middleware, create a span. And that might be something for a future stream, because I was thinking we might do something like anything that like calls get or put or post should create a span, and then we have the inner span, which is the actual call. In that case, if we did that, then I could justify setting an error span on the whole call that it timed out. But I think we'll just go with this. I think we'll just go with this adding this event for right now, because that's still useful tracing information. But we don't have to decide on behalf of the application writer whether a timeout constitutes an error that we need to flag for alerting or anything like that. So, okay, we'll start with this. So we did some copy pasta, right? And we're not changing anything here. So okay, so let's real quick. Since our open telemetry is involved, let's go ahead and make a test for this, and we will use some of the stuff from this open telemetry test that we did previously. So let's make a timeout. Oh, wow. Timeout test. Okay. And we can copy this stuff because we care about setting up OpenTelemetry for these. So this be async false. Here we're going to do plug Hardhat middleware timeout, and we'll say timeout is let's make it 100 milliseconds, so it's really short. Okay, so we got the OpenTelemetry stuff set up. Let's put another end in here. Is that right? What's going on? Yeah, sometimes the spacing on that gutter throws me. Okay. So really quick, what do we want to test? We want to test returns timeout exceeded, returns timeout error after the specified period, right? So what we can do in our bypass is we can have it sleep for, I don't know, twice the time or something, and then we will get a timeout error returned from that request. Okay. And then what we want to do is say we want to propagate, and this one is going to be harder to test, but we'll say propagates OpenTelemetry tracing context into the timeout. Not the best worded test. Okay, what else do we need to test? We need to test that adds a span event to the current OpenTelemetry span when the timeout is exceeded. Okay. And then after we've got these tests working, we'll go back and we'll look at deadlines, because I think that we have about half an hour more. I think we can get there. And I do want to introduce you, even if we don't get to that. I do want to introduce you all to the deadline library, which is really great. Okay, so this should be a pretty simple test to. So we've got the bypass in here. So we do bypass dot expect once, and this function takes the plug con, right? And what we're going to do is we're going to process sleep. We're going to sleep for 200 milliseconds, and then we're going to say plug.con.respond, and we can do something like what we did over here. Yeah, 200 hello world. Let's just copy that. Okay, so what we can do now is say error timeout test client dot get localhost bypass dot port. Okay, so that should be a simple enough test to check. Let's just run those tests. Okay, I have a syntax error. What did I do? Probably from my copy pasta. Let's have a look. Oh. Right. Okay. That's a weird syntax error. I did not expect that. Oh, and we have to do, here, let's simplify this. I made a mistake here. We're going to hard code the task module to that, and then we can refactor that later. That's not a big deal. Probably what we can do is we can say maybe at the top of our module say alias this, and then it'll just be task, and then we can call task dot await, etc. Okay. Back to our running the tests. Okay. So this is interesting. We got an exit shutdown. What's the fine help test? I want to see what caused that. So I think that we need to run it with some kind of verbose output. Dash dash trace. Yeah, let's run it with dash dash trace. Okay. Right, that doesn't tell me jack. Exit shutdown. So what I'm guessing is what we're getting here is this. And the thing is, async links to the current process. So what we might be having is when we call task module shutdown here, it's still linked. Right, so let's look at, oh, not Erlang, Elixir. So async, right, so if you start an async, you must await. This is done by calling task await or task yield, followed by task shutdown on the return task. Right, avoid setting trap exits to true. Okay, so calling await will still exit if the task is terminated without sending its result back. You want to avoid unlinking the task process started. So like you could do async no link, but that requires a separate supervisor, which we don't want to impose on people. So we could switch to yield. But let's look at the documentation for shutdown. Unlinks and shuts down the task, and then checks for a reply. Okay, so we probably need to handle a few more cases here. But one thing that we can do potentially in the meantime, where does that go? There it is I think that we can bump the delay on this test so that there's no race there, right? Because who knows? we set a timeout of 100 milliseconds, and we're sleeping for a second. We were sleeping for 200 milliseconds before. Hey, I want to just make sure that it's not a race condition issue. we're still getting exit shutdown. So there's something wrong with the order of... Oh, that's weird that it doesn't print that. Line 35, yeah. The thing is, this assertion is not failing. Let's look at shutdown again. Okay, so timeout. In the case of a timeout, a shutdown exit signal is sent to the task process, and if it does not exit within the timeout, it is killed. With brutal kill, the task is killed straight away. In case the task exits abnormally, possibly killed by another process, this function will exit with the same reason. So, okay, that doesn't apply in our case because the task we're spawning is only concerned with the parent process. Like it doesn't do, it's not receiving exit signals from anything else. It's not required to call this function when terminating the caller, unless exiting with reason normal or if the task is trapping exits. The caller is exiting with a reason other than normal, and the task is not trapping exits, the caller's exit signal will stop the task. The caller can exit with reason shutdown to shut down all of its linked processes, including tasks that are not trapping exits. Okay, if there's no process linked to the task, such as task started by task completed, we check for response or error accordingly, but without shutting the process down. Okay, it might be worth looking at the this is actually implemented because I think that is getting a bit too confusing just reading the documentation. And I want to make sure that we do the right thing here. And it's odd to me that what Tesla did to begin with is not correct. Now, it could be that we're also constructing our test incorrectly, and we need to look at that. But, okay, so let's look at what they do in shutdown. Okay, so it monitors the PID, that is the task, makes sense, and sends a shutdown kill message. So how does that relate to our error? It just says exit shutdown, right? Okay. And then it's probably waiting on, yeah, it's waiting on the monitor. Okay, so we'll have to look at the implementation of that function. All right, so this is the brutal kill branch. We're not doing the brutal kill branch. We're passing 0. So that should have a receive timeout as 0. Okay, so shutdown send. So it makes ref, it spawns a function shutdown send with the for arity, unlinks the task PID, calls exit with the reason, which in our case would be shutdown. And what the enforcer is this separate process which is unmonitored, unlinked, and it's going to make sure that that gets okay. So if it gets a done from this process, it's going to break with okay. Otherwise, if it gets a down on this process that is sending shutdown, itself will exit with PID reason. Okay, so that's shutdown send. That's what happens here. Shutdown receive is basically matching on the monitor, right? So if we, what is going on in here? So ref is the ref that was created when the PID, when the task was spawned. So it's part of that task struct. Okay. So shut down receive. Right. So if we get a down when this is shut down or brutal kill, then we demonitor that the ref. Okay. Flush reply. We'll have to look at what flush reply is. So if it's killed when the type is brutal kill, we do the same. If there's no proc, then that means the process is no longer alive. We'll have to look at the flush no proc, and then it also goes flush reply or returns reason. Okay, so okay, and then it tail calls if the timeout is reached, which would be 0. So like if these, excuse me, if we haven't received the monitor, then it's going to immediately call kill, like send an exit signal to task.pid with kill, and then go back to the top and say timeout kill. So it would potentially go on this branch if it gets a down message on that monitor. Okay, and then on the next call, it's the timeout here is infinity, right? So it's never going to hit this on the second time around. Okay, so let's look at flush reply. Okay, so if it receives this is basically like if it receives a reply from the process that we're trying to shut down, it will return with OK reply. And then that's like if the message hasn't come yet at all, it's just going to return nil. That's how we're able to do here. So the reason. So let's look at flush no proc. So if this only happens when the process is already dead, right? Okay. So flush no proc. So if we receive, so this is the original ref that's in the task struct. No, hold on. Yes, that's the original ref from the task struct. So that was the monitor, not the monitor, it's a make ref. This is the ref that was, that's got to be a monitor because this is a down message, right? So we could shut down, return nil. If it's return nil, otherwise it's down. After 0, demonitor the ref, right? Okay, down proc, no proc. Okay, so basically, let's look back at shutdown receive again. Okay, so if we get no proc as a down message, then it's going to check for, and this by the way, this is on the monitor we just created in shutdown. So we created a monitor for the PID that is the task. This is separate from the monitor that was created when the task was spawned. Okay, so we have two monitors going on here. This is why it's confusing. Okay, so in shutdown receive, if we get the monitor we just created says there's no procedure, there's no process there anymore, then we look for a down message on the original monitor that was created, so we can get why did this exit. Okay, and that's what this flush no proc is. Okay, so if we get shut down or killed, then it returns nil. If there's some other reason, then we'll get down proc reason. And then if none of those things are in the mailbox, then we demonitor the ref and we just assume that the process no longer exists for whatever reason. There's something else going on. Okay, and then finally, then we go, okay, did we get a reply on that ref that was in the task struct? If so, then we return okay in that reply. So I think that this is telling, I don't know that this is going to solve our exit problem here. And I want to look at, before we try to actually solve this, let's look at the tests for Tesla. Let's look at the timeout test, because I think it's going to tell us a little bit about what they expect. Right now here they're doing like a custom adapter, yada yada, whatever. Okay. We don't care about that. We're using bypass. Interestingly, they have a one that uses this, right? Okay. Right. So we're basically doing that. Okay, so what we could do here is that's interesting. Right. So, okay. So this is, they're basically saying this should not exit the, okay. Um, yeah, because the thing about this is, um, the error we're getting here, kind of smacks of, I'll have to maybe reboot Zed here. This sometimes happens. I can't select the shell. This smacks of the test is exiting after it's completed, because we're not getting an assertion error, right? And you note that the time that this took was just about 100 milliseconds for the entire test. So that indicates to me that the test, like the timeout we set in that test client is correct. So probably what we need to do is let's just do spawn here. Actually, let's do spawn monitor. And then we can, all right, and that'll give us a PID and a reference, and then we can wait on that, and then it won't be our test process that crashes. It'll be, we could do something like parent self. Let's just do spawn, like, because I don't think that we need to test. I mean, we could do something like they do with this trap exit, and then they're doing spawn links so that they get the exit messages. Yeah, let's do this. And we will we're doing localhost, right? Bypass port. Right. There. Okay. So yep. Let's see if this test passed now. And I'm actually going to have to change that. Make a new terminal. Because it was borked. Okay, so mix test, middleware, timeout test. Okay, so we're still getting that shutdown message. which is bizarre. And I don't, it's not clear to me what that's coming from. Now, maybe that's actually not our test. If anyone has any ideas about what to do here, because I don't actually think that that's an error. But for now, maybe we'll do skip. Let's just put timeout race condition question mark. And then we can get to these other tests, because I think that this is bogging us down in something that is not essential to the problem, but is sort of like when we had the issue of not being able to track get the actual exporter going here. Okay, so what we're going to do now for this one, so we want to make sure that the open telemetry tracing context goes into the timeout. And what I want on this particular is not to sleep. Like, I don't want it to hit the timeout, right? What I want to do is get 2 spans back. So we're going to say assert okay, and then we don't care about the env, and we'll do this again. But then we're going to do assert receive and span. But what we want to do here is actually open telemetry tracer with span, and we'll call it request. What's the documentation on this? Help. Okay. We'll just go over here. Open telemetry. What are the dependencies? There we go. Oh, right. We have to require. Did we not do that up here? Require open telemetry.tracer. Then it'll give us the macros. So we can do with span, and yeah, just call it request. Do no comma there. Okay, and then we'll put this inside. That way we have a root span going on here, and we want to make sure that we get a span that is named request, and we want to get and I think that there's a, let's look at that record. There's a field in there, API reference module. What are we including? Right, include hotel span. Okay, that's the context. What I want to know is what's in these records. So I'm not sure that's going to give it to us. Yeah, it's not going to do anything. Okay. Well, we can. Here's all our deps. Let's look at the include. Not that one. Hotel span. Not there. There we go. So what is this record? So it's got a trace ID. It's got a span ID. Really what we want to do is right. Okay, so we want to do span ID is span ID. So this will bind span ID when we're matching on this, and we want to make sure that there's a parent span ID, and we'll pin span ID. So this is going to say we opened this request span. It has this ID, and then we got from the inner call to the HTTP inner client that we put in the stack farther down, that we get a span out that is this, and I think it'll be slash based on what the OpenTelemetry middleware does. But let's see if we can run this test and get that. Yep. Okay. Bypass. I didn't match on it. Right. Okay. Right. Okay. So here is where I made a mistake. I expected that it was going to be slash, but it's just HTTP get, right? Okay. And the reason why is that we don't have any path params defined on here. So let's see HTTP get. Okay, so that 3 tests, 1 pass. Okay, so we did pass that one. We skipped one, and then we have one that's unimplemented. Okay, so the other problem here is that if we have this problem, let's do this again, just so we have the same setup for the one that passes, and then we're going to do process sleep. A second. So, and this is going to be error timeout, right? I'm just wondering about that exit that we saw before. So we should get this again, but what I want to check is there will be events, right? So events is hotel events, and surely there's which should be a list. Hotel events, see the types there. No, it's a struct events, and it has a list of event. And where is that event struct defined? Okay, so it should be defined in hotel span hurl. Right. Okay. So we have some unpacking to do here. This will be fun. Okay, so we're gonna have events, right? So looking at this struct definition, events is a field on there, which is going to be it's going to be this. So unfortunately, because this is not included in a header file, we can't match on it. We're going to have to treat it as a tuple. So it's going to be events. And then how many fields is it? 1, 2, 3, 4, 5. So 1, 2, 3, 4, and then we care about this. And let's just say this is events. And then we're going to assert that, so hotel, honestly, this should be only one span event. And the thing is, this is wrong. It's here. It's not on this one. It's on the parent, right? So we have a list of the event structs from hotel span. And what is hotel attributes.t? I think it's just no, it's one of these. Okay, so we're gonna have to do some additional matching, and there's some map that's in there, and that's what actually contains the stuff that we added as attributes. Cool. Way to go. Okay. So this is a list of events. We actually think that there's only one event. And then let's just do a assertion on matching. So event is one of the structs that's in here. And we say attributes. And that's going to be this thing. So we need to unpack that. And I really don't like matching on this sort of thing, but like I don't know that there's an API that will just give me accessors for this sort of stuff. So all right, so we've got the record marker, and 1, 2, 3, 4. The fourth thing is we care about 1, 2, 3 adders. So we're going to say that that matches event, and then we're going to, so that's the map. And what did we create in there? So in our, not in there, we added this event, and it has module. So we want to say that module is test client, and timeout is the timeout that we set. So module is test client, and the timeout is 100 adders. Okay. And we can put this above, and we know that that is okay. So there's a question in my mind about whether this is going to crash again. But let's find out. Okay. So we didn't get that span. That's actually correct, because the process was killed, right? So it's not going to emit that span. It didn't complete. If we wanted to be smart, we could go down in there and figure out how to emit that span with, oh, I was killed. But let's do refute receive instead of assert receive, because we should never get that span if the child process was killed. Okay. And let's run that test again. Let's get a check on my assumptions. Okay, so we are getting this shut down. Unfortunately, I think we might have to end the stream. I'm getting a little tired, and this is another one of those tricky things with race conditions. So I'm going to skip these two tests. Um, and then we will maybe come back to that on a future stream. Yeah, it is really odd um, that this is not. It's not telling me what process crashed here. It's just exit shutdown. This is really frustrating. So let's run before I commit this. Even with those skipped tests, yeah. So we skipped the two that are broken, and yeah, I'll maybe I'll have a Pim's cup later. Maybe Liz will be up for that too. Okay, so this is at a decent enough spot. I think that we can now. I also haven't added the documentation so for timeout. So let's do that really quickly. Oh no, we did. Okay. Um, I th- yeah. Okay, let's do a quick refactor. I want to, instead of passing this as a variable, I want to just do alias it, and then we can just call it task everywhere, and it'll look a little bit cleaner. Um, and that might be a little bit confusing because you're thinking, oh, that's the Elixir task one, but we're actually using the other. And maybe that's not desirable. And you all can, march me to the guillotine on that or whatever. Okay. We could also say as and then give it a name, like hotel task or something. But I'm not going to do that right now. One other thing that we could do in that test, because we named this event, um, this event should have a name field. Name, right? So just for completeness, let's do name is timeout exceeded. Um, and let's briefly comment this out so we can see if it still just fails on exit and not on that assertion. Yeah, just exit shutdown. So in the meantime, I will look into that before the next stream, and and we can go ahead and commit this, and you all can go about the rest of your weekend. So, okay, mix.star, and we added the new module and test. So let's look at our diff. Okay, so we added our timeout middleware. I actually want to, because I'd love to have that documentation done. Let's require required timeout in milliseconds. Yeah, Justin, I appreciate it. I would love to continue to hang out with you guys. Um, but it can be hard for me to think and talk at the same time. Um, and it's why I tend to try to prepare a little bit for this before the stream begins. But this is unexpected stuff. I don't know what's going to happen necessarily when we go to do these things. So I am kind of reaching both my limit on talking as well as my limit on thinking for this particular problem. Okay, let's look at the diff again. Okay, so we entered a timeout mode where the timeout option is required. And it's basically the Tesla middleware, but with OpenTelemetry things added to it. So we use the OpenTelemetry process propagator to do both the await and the async and the shutdown. Otherwise, the behavior is exactly the same. So we added the process propagator, and it's added to our log file. And then we have our test, which includes all the OpenTelemetry goop. I think I'll put for the next stream on a task for us to make a case template that we can use for these things that actually interact with OpenTelemetry, as well as the base one. So we could say like hardhat.otel case or something like that instead of this, the basic use xunit case. Okay. And then we have our tests, two of which have weird exits. And that's good enough to commit. Okay. Let's commit. Okay, so basic working timeout. Timeout middleware propagates OpenTelemetry context. Tests currently fail because of untraceable shutdown exit messages. Exits. Adds span event for timeout. And then I think I know we're over by my plan by about 15 minutes. But I think we'll go ahead after this commit and talk about deadlines, and then we'll pick that back up on the next stream. I really wanted to get to that, but I would rather have those tests working so that we can add the deadline functionality. But really quick, let's look at this because I have it pulled up. So this is a library. In some ways, it's almost like just the context thing from OpenTelemetry, or maybe OpenTelemetry should have deadlines built into it. But it allows you to, it doesn't do the timeout for you, but it allows you to track a global timeout as a deadline. So it uses process dictionary. It's really straightforward. You set a deadline. You can have it be set when you start a request, for instance. And we'll figure out when we address deadlines on the next stream. We'll figure out how we want to set that up. We'll probably set we'll create a middleware which propagates the deadline if one exists, and then we'll also make sure that the deadline is propagated into our timeout middleware. So if there's one thing we could also potentially do is, similar to the timeout middleware, if there's a deadline set, then respect it. but also let you set it? Let's give that some thought, um, because I think that would be a really powerful, like, out of the box, if your rest of your app is setting deadlines on requests that are propagated across your app. Um, I'm sorry, across all of the services that make up your app. Um, then you would get it automatically, and you wouldn't have to configure it. That could be really really powerful. Um, anyway, okay, so the idea is that you call deadline set. It puts a key in the process dictionary that has the time at which this deadline would expire. Um, and then if you do this exit after, what this does is it deadline has its own processes, and you can spawn a process which will send an exit signal to the current process when that deadline is exceeded, which is really cool. You can check out if the deadline is reached. Um, and then if you want to propagate it, you get the context out. So this is similar to our open telemetry propagation. And you pass it into your task, you set it inside the task, and then your await uses deadline.time remaining. So we could do something at the top of our timeout middleware, which looks like, is their deadline set? Respect that instead of the default. Use the timeout key that you passed in your options as a deadline if the deadline is not set, or further restrict the deadline that you propagate on, if it's smaller than the current running deadline. Um, so yeah, I mean, it's a very small library. Let's look at the source real quick, because it's like there's almost nothing there. Um, set, it just says this is just copying the contents in there. So this is how you repropagate it. If you're setting an initial deadline, if it's an integer, then it gets the current time. It converts that time, or I'm sorry, your deadline time into native. So this is using monotonic time, um, and then puts the start time of this thing plus the deadline in there into the process dictionary. So really, you're checking the deadline. That's really cheap. That's right in the same process. Um, this exit after. So if time remaining is like, then you don't do anything. Otherwise, so when you run the deadline app, it has its own supervisor. It starts a child, that will call exit on your process. So this is really useful if you've got like a Phoenix or a plug app. You can put a plug middleware in there, not a Tesla middleware, but a plug middleware that calls this deadline exit after you've extracted the deadline from the incoming request, and then it'll kill that request if it exceeds the deadline. And then it's also, because you called deadline set by pulling it, say, out of a request header or something, um, then you can, yeah, and you'd probably want to do like create that. Um, anyway, the um, okay, so if you're Phoenix or plug, if you're using some other framework or using plug directly, um, if that particular request hits the deadline, it'll get an exit message, and it'll just quit. Um, so you can go beyond just waiting on downstream things. You can say, well, I'm going to bail. My current process is going to bail if I hit the deadline. Um, and so again, this is all about making sure that your apps don't do unnecessary work. So you're not doing work that people aren't waiting for. Um, and then of course you can check the time remaining. You can check whether it's been reached, and that's basically like if time remaining is 0. Um, and then there's this thing that's been deprecated. But real quick, let's look at the application. Okay, so it's just got a simple monitor supervisor as the children. and right, so this is a monitor supervisor, which just calls dynamic supervisor start length. This is like simple one for one in Erlang, if you remember that. And it creates this monitor process when you call start child. It passes the deadline, the PID to kill, and before exit. I don't remember what that is, but we'll figure it out real quick. Okay, so it gets the before exit. And it just says process send after exit monitor process and the deadline. Right, so this is a function to call to do something before it exits. So I think that's probably optional, or might default to the empty function. Anyway, so yeah, so then it calls exit on the PID that you requested, and it sends the deadline exceeded exit message, which is not a standard exit message. And then it stops the current process. And then the other thing is that since it monitors the PID, if the PID is already exited, then it's like, yeah, I don't need to wait around for it. Okay, so that's basically how the deadline library works, and hopefully next time we'll get into that and add it to our library. So thank you all for coming again, and I'm all talked out, but I'm happy to answer questions for a few more minutes if you have any. And thank you for hanging on to the end. I'm going to switch to the full screen camera. If I need to switch back to answer anything about the code, just please let me know. How am I liking Zed? Well, I'd say in general it's stabler and faster than Emacs, but just like any editor, it's like I'm trying to learn something new. Like I've used Emacs for over a decade. And I think it was about 2015 or 2016 I switched to Space Max rather than my own like minimal config, and that took some learning. So it's been like 7 years since I switched editors, and I couldn't get on VS Code. I found it too clunky. So far it's been really good. I think the fact that a lot of things work out of the box is really nice. On the other hand, there are certain things like that you saw on stream. The shell, I could no longer select text for whatever reason. They've got some bugs. It's really early. But I think in general I like it. It's good for my everyday. There are some quirks where, for instance, in my day-to-day job, we have a mono repo project that is both TypeScript and a lot of TypeScript and a decent amount of Rust code. And that Rust code, most of it compiles to WebAssembly. But I can't for the life of me figure out how to get the Rust analyzer, which is the language server for Rust, to respect that I'm using the WebAssembly target in some crates, even though I am setting in the cargo settings for those crates, here is the target that we're compiling to. It'll just like gray out that section, not provide suggestions on things. It's pretty frustrating. And so there's a variety of places in our code where we're throwing up config attribute macros to comment stuff out so that it doesn't cause errors in Rust Analyzer. And it's just like, can you just do the right thing, please? But overall, yeah, I like Zed. It's pretty slick. I would recommend trying it if you're in the market for a new editor. Again, folks, thanks for coming. I think I'm going to wrap up, and I will hopefully see you next Sunday. Have a good weekend.